This is video on friction. This is the second video in the series, and we are looking at some of the problems in this video. Now, first video on friction, we talk something of basics. It is only 4 to 5 meter long video. It's worth looking at it. It's worth looking at it before you look at these actual problems. Now, the first problem which we have taken is like this. It says determine the minimum value of force P to just move the system. The two blocks are placed on rough horizontal plane. Coefficient of friction between the block A and the plane is 0.3 and block B and the plane is 0.2. Also find the tension in the string. Weight of A is 30 Newton and weight of B is 50 Newton. Now, few things we must understand out here, that no dimensions of the body are given. So rotation effect about its center of gravity are neglected, and therefore we are going to write equilibrium for only forces. That is, we are going to write sigma fx and sigma fy. We are not going to bother about sigma m. Now, another thing is, see, we want P, which will just move it. It means at this stage frictional force has reached its maximum, and that's why frictional force will be equal to mu r. So with this background, let's draw free body of both the bodies, the weights, the reactions, the tensions, and the frictional forces. Now, if these mu's values of mu's given in the problem are different for the they are not same. One is 0.1, one is 0.3, but that's okay. That will be reflected in when we substitute. So after drawing free body, for each body you write static equation of equilibrium, that is sigma fx0 and sigma fy0. So for body B, it will be P cos 30 minus 0.2 R1 minus this T is equal to 0. And for sigma Fy, it will be P sin 30 plus R1 minus 50 is equal to 0. Similar equation, two equations we'll write for this body. X direction equation will be T minus 0.3 R2, that is mu R2 is 0. And Y direction equation will be R2 minus 30 is equal to 0. Now see, these four equations we are going to try to solve. Now first two, before the fourth equation is very easy to solve. So 4 straight away gives me R2 as 30. If I put it here, 3 gives me T as 10. And then solving 1 and 2, I will get my required P. Process of solving all the sums is more or less going to be very similar, as it will be demonstrated in the next problem. It says calculate the force P required to cause the block A of weight 600 Newton to slide under block B of weight 200 Newton as shown in figure. What will then be the tension in the string? Assume coefficient of friction for all surfaces be 0.2. Alright. Now, what we do is we draw free body of every body. See the lower body, we draw all the forces. Understand them. P, the weight, reaction from the ground, and reaction from body B. See, don't mistake R2 as weight of the body. It may come, it may not come. That we'll see. But as far as body A is concerned, all it knows is it has touched surface of B, and expects a reaction, which we are giving as R2. And please note that this body A, we are trying to move towards right. So friction at top surface as well as bottom surface is opposite, and that will be towards your left. And that will be 0.2 R2 because mu is 0.2. So this is a free body. Similar free body is for the top body. See the weight, the reaction, the friction, and the tension. Now understand At this surface, the friction direction is derived from here. This is left, so this has to be right. R2 is down here, R2 is up here, because now when you are drawing free body of body B, reaction will be on the body B, okay, and that will be from surface of A. And when you keep it here, see both these vanish and you recover your this figure. Now for both these we are going to write sigma fx0, sigma fy0. So for the top body, sigma fx0 tells me this point to R2 minus x component of t cos 36.87, and sigma fy tells me R2 minus this 200 minus vertical component of, plus vertical component of t sin 36.87. These two are for the top body. Similar equations we write for bottom body. X direction p minus 0.2 R2 minus 0.2 R2 is equal to 0. That is the third. And sigma Fy equal to 0 is R1 minus R2 minus 6 is 0. Now these four equations will enable us to solve, enable us to find P. See, equation 2 and equation 1, if you solve together, you will get R2 and T. And then 3 and 4, if you solve simultaneously, substituting a value of R2, you will be able to get the P which was asked. Thank you.